Welcome back to the channel. A lot of times within the group and over comments, there's a very common question that how do we handle low latency data processing? And essentially the idea is that people are trying to perform operations at a very small time window, second level, tick by tick data, 5 second. And fundamentally the challenge that they get is getting their computations or processing, whether it's data processing or strategy execution or signal generation, completed within the required time window to avoid slippage. Now most of the people have coded in Python, so what I'm going to share in this video are some simple techniques that can help you optimize code significantly, and all of these are very low hanging. तो इनको यूज़ करके आप बहुत आराम से अपने कोड को एग्जीक्यूशन को फास्ट कर सकते हैं एंड स्लिपेजेस अवॉइड कर सकते हैं. सो लेट्स गेट स्टार्टेड. आई हैव जस्ट यूज्ड sample code. Most of this is very self-explanatory. I have not tried to actually execute the code because it's very difficult to do execution and show significant gain in terms of time for this small window, and I wasn't recording this during market hours as well, but the concepts apply in general by far and large. So the first common challenge, that two things that people do. So if you look at this code, this is a very sequential processing code. There are some imports like request, JSON and time, and then there's a function called define process market data. The process market data is just not doing anything. There's right now no operation getting done, and that's by design. However, you can have operations within it, like you could be adding some multiplication or you could be calculating some technical indicators, etc. The simulation of processing time is just to add a little bit of lag when I was running it. Then you'll have some sort of a main function where you're getting the data in URL. Your starting and ending time is basically to calculate time, and essentially this is the part which is not correct. Usually people put for loops, and sometimes people put nested for loops, and loops by design are an extremely inefficient way to process large volume of data or process data very fast. So if in your code you have loops running, please avoid loops. What can be alternatives? You can do vectorized operation, you can do broadcasting in Python, you could do native NumPy operations, or we'll look at an advanced technique up below. So avoid loops is what I'll say by far and large. And then we have just ended the processing. If you do the same kind of operation using a different library, be it Async, IO and Websockets, and Websockets are techniques about which I've talked before in another video. I've talked about all of these concepts in separate video before. I'll just put a link somewhere up top. Now what I've done here is just got the same data essentially, but we are doing it over WebSocket, and rest of the code is same. It's just an async operation instead of a sequential operation. You will not see any loop here, so it's doing an async operation with the WebSockets. And when I ran this, there's some sort of significant gain in terms of time. All right, so the amount of time taken was better in my second asynchronous processing. Now let's move further and let's go to further optimization in this. Probably the result seems to be flipped, 0.03, 0.09. This is a bigger one. All right, cool. 9, 10, 0.01, yeah, order of 3. I think I have flipped the results or something, but asynchronous performs much better. Now further optimization will just take the concept of asynchronous and WebSocket, async IO and WebSocket, and has a function called JIT, which is just in time. This is provided by a library called Numba. You can check it out, and it's a Python compilation library. What it gives you decorators, and essentially it pre-compiles the code and saves them as machine code. So it generates machine code, and just this addition of a simple decorator can optimize your code by far and large. The no Python is equals to true is just getting it into the no. It basically tells the compiler that you should generate optimized machine code without having any sort of Python overhead. So it basically does machine level translation. How it works and why it works is not that important. The important message is that this works. And here if you see, I've done a simple calculations like adjusted price, total value. All of these operations, if you do sequentially and compare it with Numba, they would be order of magnitudes faster just by running with Numba. And then if you add WebSockets and Async IO, your code will be much faster. So if you are operating within anywhere, hopefully within 1 second to 3 second to 5 second, 15 second, I'm very confident that 15 second, 5 second code you should be able to work out with this strategy and your code should finish. Now when you go smaller than 5 seconds, it really depends on the amount of data that you're fetching and throwing it here. So without looking at the volume of the data processed in one single batch, it's very difficult to comment. However, the design works for single second or 3 second data also. You might have to put in additional optimizations, and some of it I'll talk about below. You can look at completely compiling your code in the form of CPython, where basically what you will do is you will convert your Python code to it will be compiled and it will be converted to C++, and it will give you significant speed improvement, because remember, Python is not a compiled language, it's an interpreted language and it has an overhead. Second, if you are dealing with large data, always try to use raw NumPy or Pandas, both of which are very efficient. Lastly or lately, if your code is or if your strategies are very complex, or if you're doing things like you're doing like pair trading and you're running pair scans of the orders of significantly large magnitude or even triplets, etc., where you need multiprocessing and fast execution, you can leverage libraries like multiprocessing libraries, where your computation can be parallelized over multiple CPUs. If you need to further go beyond this, like your requirements are really of running a prop trading firm and you have very complex strategies, CPU computationally expensive strategies like heavy quant strategies, or strategies that rely on running a lot of simulations before and then selecting, or strategies that are doing optimization first and then deciding in a short period of time, you should look at point 4 and 5 in much more detail, like go to a compiled language like C++ or Rust and do multiprocessing. Alright, so hope some of these techniques are helpful to you. If you want to have ask specific questions, if you want to start to gather into an engaging conversation, please do join the WhatsApp group. It's completely free of cost, no strings attached. It's a community led effort. And until my next video, please subscribe, like, you put in a comment if you have liked the video, put in a thumbs up and share too. Thank you. Bye bye.